Hello students, this is Sandhya, Assistant Professor of Chemistry from Department of Sciences and Humanities, MATRUSRI Engineering College. Now today let's discuss about something called biodiesel, which is a subtopic in your Unit 6, and we are going to deal with the importance of the biodiesel and how actually the characterization of biodiesel is observed and what are the advantages of biodiesel over the other forms of fuel forms like the petrodiesel. So this is actually a topic which is considered to be very important in the present scenario, as we are looking for the alternate resources of energies other than the natural resources that we have, because they are exhausting in nature, and we need to also find the alternate resources which can be compatible to the environment. So biodiesel is one such possibility which has both the requirements fulfilled. That is, we are able to address the problem of the conservation of natural fuels. At the same time, we have a solution for the environmental problems. That is, reducing the environmental pollution could be done using biodiesel. Biodiesel is considered to be a source of renewable energy. Now, when we talk about renewable energy, please remember this is a term used to address those resources which can be regenerated. That is, for example, if you have plants, when you are utilizing the plant resources and when they are cut down, you can again plant them up and you can generate them again. But it is not the case with the regular natural form of fuels that we extract from the natural resources, that is like petroleum, coal, etc. They are actually the fossil fuel forms which have undergone changes for millions of years together, so they cannot be regenerated and reproduced. So this biodiesel is considered to be one major alternate resource which is actually renewable form. So we have the possibility of regenerating the resource and make use of them constantly. So biodiesel is a plant source. So it is a natural, renewable plant source material which can be used as a domestic fuel. And this biodiesel is considered to be a kind of replacing the diesel forms of fuel. And the characteristic features of biodiesel are considered to be very close to that of diesel, and so many studies are research are carried out on this biodiesel. Now let's talk about what exactly this biodiesel is. It is a natural, renewable, domestic fuel alternate for diesel engines made from vegetable oils, mostly soya and corn. And we have found the most very important kind of a resource from jatropha seeds. So vegetable oils are produced from the sources like you have the groundnut, the soya, jatropha, etc. So all these oil sources are utilized in order to generate biodiesel. So it's been studied that the plant extract oils are proving to be almost similar to that of the diesel that we have from the petroleum deposits, that we extract from petroleum deposits. So vegetable oils contain majorly triglycerides. You have glycerides, which are the sources of fatty acids, which are actually the fatty acids along with the glycerides, which are present in the oils, are actually present in the vegetable oils. 90 to 98% of triglyceride forms are present in these plant oils or vegetable oils. Now, along with those 90 to 98% of triglycerides, we may have monoglycerides, phospholipids, phosphatides, carotenes, etc. Carotenes, as you know, they are vitamin A resources. So, they may be present along with these triglycerides, that is, along with fatty acids and triglycerides in oils, vegetable oils. So triglycerides are ester forms. Okay. Now how these esters are usually formed? They are the combined state of the alcohols and carboxylic acids. Now when carboxylic acids and alcohols, when they react, esters form. That's called as esterification, right? So these ester forms are triglycerides which are present in vegetable oils. Now, esters of long chain fatty acids such as stearic acid, palmitic acid, linoleic acid, oleic acid, etc. will be present in vegetable oils. Now, majority of the biodiesel that we have is produced from the seeds of Jatropha. This plant extract is actually the best resource of biodiesel. And these vegetable oils, that is, suppose if you are extracting the oils from Jatropha seeds, these oils cannot be directly used as the fuel form. Now, as you know, we have already discussed, triglycerides are present in major proportion. Now, whenever there are triglycerides which are present, the viscosity of the oils is usually high. So, when they are highly viscous, they cannot be as such used. As you know, petroleum is also a highly viscous form of a liquid. So, we try to actually carry out the fractional distillation and get the proportions of several hydrocarbons in such a way that they're conveniently used for various purposes, especially in running the internal combustion engines. Similarly, biodiesel is also extracted from the vegetable oils, but these extracts cannot be directly used because of their high viscous nature. So, high viscous forms of fluids cannot be used directly in engines. So, internal combustion engines have to be fed with proper forms of fuels. So if biodiesel is directly extracted and used up in fuel as a fuel in engines, it may not be an effective form of a fuel. In turn, it may cause a lot of problems in running the engines. So in order to prevent all these problems, to make it more feasible in its usage, we are trying to actually reduce the viscosity of the fluid or the liquid that we have extracted from the seeds by carrying out a process called transesterification. Okay, so what is basically this transesterification reaction? So as we see, the transesterification is actually the process by which we actually have the triglyceride forms present in oils, isn't it? You are able to see these triglycerides, right? So 1, 2, 3. These are the alkyl forms. R1, R2, R3 are the alcohol forms, alkyl groups. And you have the tri-ester linkages present over here. You're able to see, right? C double bond O, O is the ester linkage which is present. So, transesterification is the process which is actually used in order to make sure that we have the triglycerides broken into the form of monoglycerides. These are the monoglyceride forms. You are able to see, right? R1, R2, R3 are no more connected. They are single or monoalkyl groups now, right? So here we have the conversion of triglycerides into monoglycerides, and these monoglycerides are less viscous than the triglyceride forms. So conversion or exchanging of the alkyl groups of esters with the alcohols is done majorly in case of the transesterification reaction. The process of exchanging the alkyl group of an ester with alkyl group of an alcohol. This is transesterification, a simple exchange of alkyl groups from alcohol to ester and ester to alcohol. These reactions can be catalyzed by using acids, bases or enzymes. So again, they have a specific catalyst used. You could use base catalyst like sodium hydroxide or an acid catalyst or enzymes. The natural catalysts that are present in the biological systems can also be used in engaging this process. Now, as you know, the triglyceride forms which are present in biodiesel are treated with alcohol, that is methanol. This is monoalkyl alcohol. So this monoalkyl alcohol, methanol, is allowed to react against the triglyceride forms, and this reaction leads to the transesterification, that is exchange of alkyl groups, where you have the glycerol formed. You just observe now on the product side, it is 3 carbon chain of alcohol groups. Trihydroxy groups are formed over here, right? And then what is happening to the esters? There are single alkyl groups present with each ester molecule. So you have broken down the triglyceride forms into monoalkyl esters. So these are the methyl ester forms which are formed at the end of the transesterification reaction. So you are reducing the viscosity of the biodiesel by turning out the triglyceride forms into monoglycerides. So this reaction reduces the viscosity of the liquid so that they can be properly used for various purposes. That is, it can easily replace the petrodiesel form with the biodiesel form. Okay. Now let's look upon the properties of biodiesel. The color of biodiesel ranges from golden to dark brown depending upon the production method. Usually the viscosity, at the same time the procedure by which the whole reaction is carried out may vary with the color imparted to the solution as well. So golden to dark brown can be the change with the production method that is usually used. And it's slightly miscible with water, has a high boiling point and low vapor pressure. And when you observe the calorific value of biodiesel, you can see that the biodiesel has less calorific value compared to the petrodiesel. But of course, because of its availability as a renewable source, we prefer to have this as an alternate source over the petrodiesel. This is about 37.27 megajoules. This can be otherwise read as million joules as well. The calorific value of biodiesel is about 37.27 million joules per kg. This is about 9% lower than the regular petrodiesel. Now, apart from that, the flash point of the biodiesel exceeds about 130 degrees centigrade, significantly higher than that of petroleum diesel. which may be as low as 52 degrees centigrade. So this is another property variation from the petrodiesel. The biodiesel has much variation with the density as well. So it's about 0.88 grams per centimeter cube, whereas the petrodiesel has a density of about 0.85 grams per centimeter cube. So these are various changes that are occurring with the petrodiesel to that of the biodiesel. Now let's look upon few significant features why we have to use biodiesel in place of petrodiesel. First and the foremost thing, you must have heard about the proposals of banning the diesel engine automobiles in the present scenario, because diesel engines using diesel as the fuel have more possibility of generating pollutants, more amount of pollutants into the atmosphere, because the carbon chain is longer with diesel, and hence there is more carbon emission that is possible during the burning of the fuel. So one major advantage of biodiesel stands to be that it has reduction of pollutants that contribute to smog and global warming. Actually, when you talk about the pollutants from the automobiles by burning the fuel, it is contributing to global warming. So that's actually being reduced if at all biodiesel is used as a regular fuel in place of diesel. And it can omit up to 85% fewer cancer causing agents. As I told you, when carbon emissions are present in atmosphere, it may be carcinogenic in its effects and causing lot of problems other than cancer as well. There are many health hazards caused by these pollutants. So these cancer causing agents or other kind of health hazard producing agents can be reduced in the atmosphere by using biodiesel, because biodiesel burns much clean, okay, and at the same time the amount of carbon emission is reduced with biodiesel. As we have seen, the triglycerides that are present are broken into monoalkyl esters, and so the amount of carbon that is burnt is considerably less than the regular petrodiesel. So that's one major advantage of using this renewable source. And apart from that, we have greater possibility of regenerating this source of energy. We can produce jatropha seeds as many times as possible during the seasons. So we can regenerate this energy resource. So that's one major advantage. And apart from that, it is equally energy efficient like that of diesel. So this is major advantage of using the biodiesel as an alternate source of energy in place of diesel. And of course, apart from the advantages, we encounter limitations, but there are few, of course. So generally has high cloud and pour point. So it will freeze at higher temperatures than conventional diesel. And at the same time, it is not compatible with some of the metals and plastics. So when you are using this diesel in containers made out of specific metal forms or plastics, it may cause certain undesirable reactions. And so this is one particular drawback that we have with biodiesel. So this is again one major limitation that we encounter with biodiesel. But other than that, this is considered to be a major renewable resource which can replace the diesel forms which are obtained from the petroleum resources. And biodiesel is considered to be helpful in attaining carbon neutrality. So we'll talk about, we have talked about carbon neutrality as well. We know what exactly we want with carbon neutrality, that is less of the emission of those gases which cause the greenhouse effect, right? So with this I end up with this lecture, and thank you.